Hi class, this is Sir Alex Basco and welcome to our lesson in General Chemistry 1. Today we are going to start a new discussion on lesson 6, which is the mass relationships in chemical reaction. This is basically a continuation of stoichiometry. More specifically, we are going to apply everything that we've learned so far about basic stoichiometry, and we are applying them in various chemical reactions. So from the things that we've learned in lesson 5 in how to measure molar masses, things like that, we are going to apply everything and use it in mass relationships in various chemical reactions. So at the end of today's lesson, what I want everyone be able to do is first construct a mole or mass ratios for a reaction in order to calculate the amount of reactants needed or the amounts of product formed in terms of moles or mass. What this basically means is for you guys to be able to calculate how much reactant you need in order to form a certain amount of product, or to identify how much product is formed if you are given a certain amount of reactant. And in order for you to do that, you have to understand how to create a mole or mass ratios between the reactants and the products. That's what we are going to do today. Moreover, in this lesson, we will also be calculating percent yield of the reaction and explain the concept of limiting reagents and excess reagents or reagents. So for this part of the lesson, we will be dealing with number 1 and number 3, and the second part, which will be uploaded on the next time that the lesson will be uploaded, will be focusing on percent yield. So for now, let's focus on number 1 and number 3. So the main important thing about stoichiometry is understanding that the law of conservation is applied in chemical reaction. What that means is the amount that you started with, or the reactants, however amount of reactants you have, everything should be conserved, meaning the amount of products that you will produce from the reaction of those reactants should be the same amount. That is the law of conservation. So let's take this combustion process for example. So we are burning methane gases. So by combining 1 mole of methane gas on 2 moles of oxygen, which is a combustion process, we are creating carbon dioxide and water as our products. So let's look at the mass of our reactants, which is this side, and the mass of our products, which is on this side. So looking at this table, you can you guys I hope you remember how to do this. Trying to measure the molar mass of each of these individual compound, you would notice that the total amount of product or the total amount of reactants in grams is actually equal to the total amount of your product in grams. So this is the law of conservation of mass. Nothing is basically wasted, at least theoretically, but when you start actually doing chemical reactions in real life situation, this may not be true, but theoretically this is how we solve for a lot of chemical reactions. But of course there's human error involved, so sometimes a certain amount of chemical is missing on the product. But again, this is theoretically, and since stoichiometry is a lot of theoretical explanation and theoretical problem solving stoichiometry, we are following this idea of law of mass conservation. So in stoichiometry, this is important because in order for us to be able to apply or calculate however or how much reactant we need in order to create a certain amount of products, or in order to measure how much product we are going to get from a certain amount of reactants we are given, we have to understand that there is a relationship between our reactants and our products. And this relationship can either be in mass to mass, so the mass of your reactants is equals to the mass of your product, or it can even also be in terms of moles. So the amount of moles in your reactants are also relatively equal to the amount of moles in your product. And not only that, even in volume. So the amount of reactants per volume is theoretically should be equal to the amount of volume in your product. And this relationship here is what we actually call the stoichiometry relationships, or the stoichiometry mass relationships. So being able to identify this, you can actually now calculate how much reactants you need in order to create a certain amount of product. Or if you are given a certain amount of reactants, then you can calculate how much product you will get. So let's look at this sample problem. To produce 3.4 moles of H2O, how many moles of oxygen are needed? So we know that in order for us to create H2O, we need to use a synthesis reaction between hydrogen and oxygen. The first thing that you have to know in order to solve stoichiometry is one of the first important thing is a balance equation. You have to make sure that your equation is balanced. Unless your equation is balanced, your stoichiometry solution is actually going to have a problem. So you want to make sure that the first thing that you have to do is to make sure that your reaction is balanced. So if we look here, let's check whether our reaction is balanced. So we started with 2 hydrogen and 2 oxygen, but if we look at our product, we ended up having 2 hydrogen but only 1 oxygen. So it means we do not have a balanced chemical equation. So in order for us to balance this, let's try to add 2 here in order for us to have about 2 oxygen, but this time we ended up having 4 hydrogen. So in order to balance this, we just have to add another 2 in front of the hydrogen in our reactant. So in this scenario, we ended up having 4 hydrogens and 2 oxygens in our reactant, and the same thing, 4 hydrogens and 2 oxygens in our reactant. So this way our equation is now balanced. So the first thing that we have to do again is balance the equation. So after balancing the equation, we can now solve for whatever we are looking for. So let's write our given. So from the problem, we are given 3.4 moles of H2O. And we know that this H2O is actually our product. And what it's asking is how much oxygen do we need in order for us to create 3.40 moles of H2O. So it's asking how many moles of oxygen we need. So after identifying our given and what is being asked, so let's try to go on our solution. Under solution part, the next thing that you have to figure out, number 2, is to find the relationship between your product between reactant and product. Why is this important? Well, this is your mass relation, or in this situation, it's a mole relationship, since we have a moles of product and a certain moles of our reactant. So find the relationship between your reactant and your product. So how are we going to find this? In order for us to find this relationship between moles, because we are given moles, we have to look at your balance equation. This is why it is important to have a balance equation. You have to find the relationship of moles of your H2O and the moles of relationship in O2. So if you look here, you have actually 1 mole of O2 and 2 moles of oxygen in here, or in every H2O. So what that means is you have a relationship of 1 mole of oxygen in every 2 moles of H2O. This is your molar relationship in your stoichiometry. So after identifying this, again, you can find this in your balance equation. This is 1 mole because you only have 1 mole of oxygen. But in this situation, you have 2 moles of H2O. So the relationship between oxygen and H2O is 1:2. So this is important because now you are going to use this relationship to find the moles of oxygen. So number 3, let's find the mole of oxygen. So in order for us to find the moles of oxygen, what we are going to start with is to take the initial amount of our product. This is our product. So let's begin with 3.40 moles of H2O. So that's this is a given, and what we're going to do is to multiply this with our stoichiometry relationship, putting the product in the denominator so we can cancel H2O. So meaning in every 2 moles of H2O, we always have 1 mole of O2. So after that, we can actually now solve for the moles of oxygen because the moles of H2O is cancelled. So what's left is moles of oxygen. So 3.40 multiplied by 1 divided by 2. That is the amount of oxygen, or the amount of moles in oxygen you need in order to create 3.40 moles of H2O. So that is actually equal to 1.70 mole of O2. So that's how you are going to solve for a mole-to-mole relationship. It's easy because you're solving for the same units. You're solving for the same mole. It's going to be a little complicated when you start solving for a relationship between mole and, let's say, mass in terms of grams. This is where you start putting in what we studied previously, looking for the grams per mole of each of the compound. Dito na pumapasok yung molar mass of a compound. But for now, let's keep it simple. We are just looking for the same units. But if you started looking for different units, that's still possible. Ipapasok nyo lang dito yung grams per mole. But again, this is how you solve this problem. Now let's look at another sample problem. How many grams of carbon dioxide can be formed from the combustion of 7.34 grams of methane, or CH4? So again, the first thing that you want to do in here is to understand check whether you have a balanced equation. So this is our given equation. Now let's check if we have balanced equation. So let's look at our reactants. Our reactants is methane and oxygen. So we have 1 carbon. Then let's see if we have 1 carbon in our product. Yes, we have. Now let's check how many oxygen or hydrogen do we have. In our reactants, we have 4 hydrogen. But in here, we only have initially 2 hydrogens. So in order for us to balance this, we have to add another 2. So by adding 2 here, we ended up having 4 hydrogen. But that also affects the number of oxygen we have, which means we have 2 oxygen here. So 2 oxygen here, another 2 oxygen there. It means our total oxygen for our product is 4. Then let's look at the oxygen in our reactant. We only have 2, which means in order for us to balance this, we just have to add 2 here to have 4 oxygen in our reactants. Now let's check whether our chemical equation is balanced. So we have 1 carbon, which is 1 carbon on each side. We have 4 hydrogen in our reactant, and we also have 4 hydrogen in our product. We have 4 oxygen in our reactant, and we also have 4 oxygen in our product, which means our chemical reaction is balanced. So after identifying that, let's now look at the given. So we are given 7.34 grams of methane, and what is asked is how many grams of carbon dioxide can be formed from the combustion of 7.34 grams of methane. So meaning our methane is our reactant and our carbon dioxide is our product. So we are looking how much product can be made, or in more specifically, how much carbon dioxide can be made from combusting 7.34 grams of methane. So let's head on to the solution. Again, the first thing that you want to do is to look at the relationship between your reactant and your product. So look at the relationship between COH4 and CO2. So from this equation, these are the relationships you are looking at. So it means our relationship is in every 1 mole of CH4, you actually have 1 mole of CO2. Meaning our stoichiometric relationship is 1 grams is to 1, or 1 is to 1. Next, what we are going to do now is to solve for the grams of CO2. So in order for us to solve that, let's begin with our given amount of reactant. So we have 7.34 grams of CH4, and then after that you can see that this stoichiometric relationship is in moles. So we cannot immediately just use 1 mole of CH4 in every 1 mole of CO2, because this is in grams, this is in moles, they won't be cancelled. So what you want to do is find the molar mass of CH4. So what that means is we have to find the molar mass of CH4. So carbon and hydrogen. The molar mass of carbon is actually about 12, and you only have 1 carbon in our CH4, so that's times 1. That gives you 12 grams of carbon. As for hydrogen, we know that in every 1 hydrogen, that's 1 grams. We have 4, so that's times 4. That gives you about 4 grams. So CH4 is actually about 16 grams. And more specifically, it's actually 16.042 grams. So now you have your grams in CH4, and this is actually 16.042 grams per mole. This is your molar mass. So you can use this now to change change your grams to moles. So in every 1 mole of CH4, it's equivalent to 16.042 grams of CH4. What you can do now is you can cancel the grams in CH4. You are left with a mole of CH4. But we're not done yet. What we are looking for is the grams of CO2. Now this is where you would apply the molar relationship because you are now in moles. You know that in 1 mole of CH4, there's 1 mole of CO2. So you're just going to write 1 mole of CH4 in every 1 mole of CO2. So the moles of CH4 is cancelled. The next thing that you have to do now is you have to find the grams, but this is in moles. You have to convert this into grams. How you are going to do that? This is where molar mass again comes into place. You have to find the molar mass of CO2. Again, we know that we have 1 carbon, and 1 carbon is equals to 1 grams per mole. So 1 grams per mole times 1, that is still about 12 grams per mole. And for oxygen, oxygen is actually about 16 grams per mole. And since we have 2, so that's 16 times 2, that is about 32 grams per mole. So 12 grams per mole plus 32 grams per mole, that is about 44 grams per mole. And more specifically, that is actually about 44.01 grams per mole. So now you have your molar mass in CO2. So we know that in every 1 mole of CO2 is equivalent to 44.01 grams. So you can cancel your moles, and what's left is grams in CO2. So just plug in all of that in your calculator. 7.34 times 1 divided by 16.042 times 1 times 44.01 divided by 1. And that is actually equal to about 20.14 grams of CO2. Which means if we begin with 7.34 grams of CH4 as our reactant, our theoretical product is 20.14 grams of CO2. So that is how you measure, or this is how you find, calculate the amount of reactant or the amount of product from a given amount of reactant. And this relationship is in grams per grams. And as you can see, since the chemical reaction, the chemical equation deals with moles, you have to use the molar mass of the compound. That's why we study this first in order for you to solve the molar mass of a compound, because you have to be able to convert between grams and moles of a specific compound. So I hope that is clear. If you guys have any question about this, do not hesitate to message me. Let's go on to another sample problem. How many grams of chlorine is required to react with 17.30 grams of aluminum to produce AlCl3? So a lot of situation also in stoichiometry is not only a relationship between reactants and products. It can also be a relationship between a product to product, or even reactant to reactant. You can still create this smaller relationship. It's not always reactant to product. So again, what we want to do is to make sure we have a balanced equation. So let's check whether our equation is balanced. So we start with 1 mole of aluminum, and our product has 1 mole of aluminum. So that checks out. But in here, we have 1 mole of Cl2, but we have Cl3 here. So we have 2 chlorine here and 3 chlorine here. So how can we balance? What can we do to balance the number of chlorine on each side? Well, the best thing that we can do is by adding 3 here, which means by having 3 Cl, that would give you 6 chlorine on your reactant, and by adding or having 2 moles of AlCl3, that means your number of chlorine in your reactant is also 6. But as you can see, that affects the number of aluminum, and that is easy to handle because we just have to add 2 here. So in this case, we have 2 aluminum here and another 2 aluminums in our reactant. So now we have a balanced equation. So after balancing your equation, let's write our given. So as for given, we are given 17.30 grams of aluminum. As we know, this is our reactant. And what it's asking is how much chlorine or Cl2 we need in order for us to fully react 17.30 grams. So it's asking grams of chlorine, which is also a reactant. Again, the stoichiometry relationship is not only for product and reactant. It could be on product to product or even reactant to reactant. In this situation, you are looking how much Cl2 you have to add to Cl3 in order to fully utilize or fully use all 17.30 grams of aluminum. So let's look at the stoichiometry relationship between your aluminum and chlorine. We know from the chemical equation that in every 2 moles of aluminum, we need to use about 3 moles of Cl2. So our stoichiometry relationship is 2:3. So in every 2 moles of aluminum, you need 3 moles of Cl2. So let's write our solution. So how can we find the grams of Cl2? Well, again, you have to start with what was given to you, which is 17.30 grams of aluminum. And similar with the previous example, since we are dealing with grams, we have to first convert this into a mole because our stoichiometry relationship is in moles. So let's try to find the molar mass of aluminum. And this is easy. Just look for the periodic table to find the molar mass of aluminum. And that is actually equal to 26.98 grams per mole in aluminum. Again, this is the bottom number. So if this is your aluminum, you have your number here, another number there. The bottom number is the number that you have to take. So that means that in every 26.98 grams of aluminum, that is equal to 1 mole of aluminum. So now that we are in moles, we can now use our stoichiometry relationship of 2:3. And we know that in every 2 moles of aluminum, in our reactant, we need 3 moles of Cl2 in order to fully use all aluminum. So the aluminum gets cancelled. We have 3 moles of Cl2 left. Since we are looking for grams, well, if you're let's say if you're looking for mole here and not grams, then this is done. You just have to compute this. But since we are looking for grams, we have to convert this 3 moles of Cl2 to a grams of Cl2. And you just have to find the molar mass of Cl2. So since this is just an element, just look at the periodic table and identify the mass of Cl. And mass of Cl is actually about 35.45 grams per mole. And since we have 2, you just have to multiply that to 2. That is equal to about 70.90 grams per mole of Cl2. So meaning in every 2 moles, or sorry, in every 1 mole of Cl2, you have about 70.90 grams of Cl2. So the moles of Cl2 gets cancelled. Then you just have to plug in all of this into calculator. 17.30 times 1 divided by 26.98 times 3 divided by 2 times 70.90 divided by 1, and that would actually give you about 68.19 grams of Cl2. So that's how you solve this sample problem. So meaning in order for you to react all 17.30 grams of your aluminum, you need to add 68.19 grams of Cl2 so that all of those aluminum will combine to chlorine to create AlCl3, and you don't have any excess. So speaking of excess, let's go to our next topic, which is what we call the limiting reagent. So what is a limiting reagent? Simply put, limiting reagent is the one that limits how much product is formed. Another thing that you have to remember about limiting reagent, it's that it's the first chemical, or it's the first substance in your chemical reaction that is fully consumed first, and that makes sense. So for example, you have two reactants, two chemicals as your reactants. Both of those reactants are acting onto each other. If one of those reactants were fully utilized, meaning naubos na siya, pero yung isa pang reactant is hindi ubos, meaning meron kang excess or meron kang natirang reactant. And yung natirang reactant na yon, since wala na yung naubos na yung isang reactant na kailangan niyang makasama, hindi na magbubuo yung natirang reactant into a product. And that is why we call the yung unang naubos na chemical or substance as the limiting reagent. You can also see this as a limiting reactant. Sometimes you would also see this as limiting reactant. So it determines how much product is formed in the reaction. So let's take for these as an example, so I hope it's clear. So let's say this is your reactants and this is your product. So you started with 5 hot dogs and you have 4 buns. And ang gusto mong mangyari is, ang gusto mong product is magkaroon ka ng hot dog sandwich, right? But if you notice, you only have 4 buns but 5 sausage. So, alin dito yung limiting reactant mo or limiting reagent? Well, I hope you can see now why, I hope you can see it now. Your limiting reagent is the buns. So, bakit limiting reagent si bread? Well, again, this determines how much product is formed. So 1 buns get consumed in every 1 hot dog. So you have, so 1 hot dog gets cancelled, 1 buns gets used, you create 1 hot dog sandwich. Another hot dog and another sandwich is produced, you create another hot dog sandwich, and so on and so forth. But as you can see, naubos na yung reactant mo. So, one of your reactants is already fully consumed. Naubos na siya. But meron kang natira na isa pang reactant. This reactant will not produce any more product because it's missing another, or it's missing the other part that it needs to react with. So magiging product mo in the end is your theoretical, this is what we call our theoretical amount, and this is what we call the excess reagent. Excess kasi hindi siya fully consumed, may natira siya. And this is our limiting reagent. Limiting kasi this is the one that is consumed first, and it determines how much product is formed. So I hope that is clear. So now let's take a look at our example. A reaction between methane, CH4, and oxygen, O2, was carried out in a closed vessel. In a closed vessel, 0.50 moles of O2 was used to burn 3 moles of CH4. Find the limiting reagent and calculate the theoretical yield for CO2 in terms of grams. So again, the first thing that you have to have is a balanced equation. So let's check whether our equation is balanced. So if we look here, in our product or reactant, we have 1 carbon. We have another 1 carbon in our product, so that checks out. So we have 4 hydrogen in our reactant, but we only have 2 hydrogen in our product. So we have to add another 2 hydrogen in our reactant to balance the 4 hydrogen in our product, to balance the 4 hydrogen in our reactant, and that checks out. But what that means is we added also another oxygen in our product, which means we have a total of 4 oxygen in our product, but we only have 2 oxygen in our reactant. So by adding 2 more oxygen in our reactant, that balances everything out. So now we have a balanced equation. So after balancing our equation, let's now write our given. So from the problem, we are given 0.50 moles of oxygen, and then this oxygen is used to burn 3 moles of CH4, correct? And then what is being asked is, first, your limiting reagent, and second, what is the theoretical yield. So let's head on to the solution. Solving limiting reagent can be done in many ways, but I'm going to teach you 1 or 2 ways. The first one is just pure analysis, okay? So the first thing that you want to look in limiting reagent is to identify the relationship between your reactants. So you know that from your chemical equation that in your reactant, that in every 1 mole of CH4, you have it has to react with about 2 moles of O2, meaning the relationship or the stoichiometry relationship between your reactant is 1:2, correct? Now I want you guys to look at this and look at your given ratio. So the one that you need is, or let's write need, is 1:2. 1 mole of CH4 in every 2 moles of O2. But what you're given is 0.5 is to 3. So if you look now, what is your limiting reagent? Again, from the need from the analysis of the relationship, stoichiometry relationship, you know that you need 1 mole of CH4, but you're only given half the amount of that. And then let's look at or that's CH4, that's O2. But now let's look at, sorry, this should be here. But you're only given, it's not even half, it's about 1/4 of that. Sorry, this 2 here is for O2. So in your need, you need 2 moles of oxygen, but you were only given 0.5 moles. That is not enough. That is already your key. The given moles of oxygen reactant is already not enough. Now let's even check CH4. In order for you to fully to have a full reaction, you need only 1 mole of CH4, but you're given 3 moles of CH4. It is more than enough. It is 3 times the amount of you need. And for oxygen, it is about only 1/4 of the amount you need. So that already tells you that your limiting reagent is oxygen. So we've answered the first question. What is the limiting reagent? Another way on solving this is to actually find how much of these amount will actually give you. So what that means is, from the previous 2 examples, use this, and then if you have this, how much of the product you can make. And if you have 3 moles of CO4, how much product of 3 moles of CH4 can you make? And from that, I'm not gonna do that anymore here, but it's basically the first 2 examples that we did. What you will notice is you ended up having a smaller amount of product for O2, and identifying which one has the smaller amount of product, that tells you which is your limiting reagent. And if you do that, use 0.5 moles and solve for whichever of this product, total product it will give you. It will actually show you that your limiting reagent is O2. So I hope that is clear. So it's just basically what we did previously. Okay, so you are given these amount and solve for how much product 0.5 of O2 gives you. Also solve for how much product, it could either be CO2 or H2O, it's up to you, but use the same thing. So check how much CO2 0.5 moles of O2 gives you, and how much CO2 3 moles of CH4 gives you, and find the smaller amount. And from there, you would actually that your limiting reagent is 0.2. So now we're going to do is we are going to find the theoretical yield. In the second part of the lesson, I'm gonna explain what do we mean by theoretical yield. Okay, but for now, let's use this term here, theoretical yield. Theoretical yield is basically what we've been doing. So the first 2, the other 2 problems we've solved, that is actually the theoretical yield. So in order for you to solve this, so you're looking for the theoretical yield of CO2. So you're looking for grams of CO2, and then what you are going to use here is use your limiting reagent. Why do you need to use your limiting reagent? Because again, this is the one that determines the amount of product that you will get. So you have to use 0.50 moles of O2, because if you use 3 moles of CH4, that is not your limiting reagent. This does not dictate how much product you will make. So after using your limiting reagent, now you can find the grams in CO2. The only thing that you have to find first is find the molar mass of O2, which is always about 16 grams. So that's about times 2, that is 32 grams, right? Oh, no need. No need to do that, sorry. This is for CO2. Okay, so you just have to find the relationship between CO2 and O2. And you know that in every 2 moles of O2 is about 1 mole of CO2. So just write 2 moles of O2 here and 1 mole of CO2. So the moles of O2 gets cancelled. And then since we're looking for grams of CO2, this is in moles, you have to find the molar mass of CO2. So you have your carbon, which is 12 times 1, so that's 12. You have your O, which is 16 times 2, that is about 32, so about 44 grams. More specifically, that's 44.01 grams. So in every 1 mole of CO2, that is equivalent to 44.01 grams of CO2. So moles of CO2 gets cancelled, and ultimately your answer is about 0.50 times 1 divided by 2 times 44.01 divided by 1. So that is about 11.0 grams of CO2. So in 0.5 moles of O2 and 3 moles of CH4, you would get 11.0 grams of CO2, only 11 grams because you have a limiting reagent of 0.5 moles of O2. So I hope that is clear. If you guys have any question about this, do not hesitate to message me. We are going to continue on the second part of the discussion, but for now let's stop it here so that the video is not too long. Thank you so much guys, and you guys have a great day.